Hello friends, today we are going to see chapter number 4 from NCERT CBSE book class 9 Structure of an Atom. In chapter 3 we have learned that atoms and molecules are the fundamental building blocks of matter. हमने पहले लेसन में यही देखा है कि कौन सा भी मैटर हो, कौन सी भी चीज़ हो, कौन सा भी सब्सटेंस हो, वो एटम से या मोलिक्यूल से बना हुआ होता है. The existence of different kinds of matter is due to different atoms constituting them. Now the question arises, what makes the atom of one element different from the atom of another element? Atoms एक दूसरे एटम से कैसे अलग हो सकता है? Are atoms really indivisible? Atoms रियल में इंडिविजिबल है या कोई उसका बाद में छेद भी हो सकता है? ये जो पूरा सिस्टम है, now we are going to see in this lesson. We shall find out the answers to these questions in this chapter. We will learn about subatomic particles and the various models that have been proposed to explain how these particles are arranged within the atom. One of the first indications that atoms are not indivisible comes from the studying static electricity and the conditions under which electricity is conducted by different substances. Now question arises, what is the static electricity? The static electricity result of imbalance between negative and positive charges in an object. When two different objects, they show the positive and negative charge, these types of charges are known as the static electricity. For example, अभी हम यहाँ एग्जाम्पल के दौर में ये देख सकते हैं, जब हम दो बलून्स गुब्बारे एक दूसरे के ऊपर जब घिसते हैं तो वो जो गुब्बारे होते हैं उनमें इलेक्ट्रिक चार्ज पैदा होता है. नहीं, when we rub the balloons on dry hair, that hair will be float in the air in upside direction. So that is the example of static electricity. Point number 4.1, charged particles in matter. For understanding the nature of charged particles in a matter, let us carry out the following activity. Given activity is there: comb dry hair. Does the comb then attract small pieces of paper? Yes, they can attract. B. Rub a glass rod with a silk cloth and bring the rod near the inflated balloon. Observe what happens. So that is the small activities given here. You have to observe that activities. From this activity can we conclude that on rubbing two objects together they become electrically charged. Yes, they are electrically charged. Where does this charge come from? After rubbing, that charge created. This question can be answered by knowing that an atom is divisible and consists of charged particles. When we rub these two objects on each other, then they are carrying the both charges, positive and negative. Many scientists contributed in revealing the presence of charged particles. In 1900, what happened? In that time, scientist J.J. Thomason, he discovered that atoms is not divisible, means it is indivisible. साइंटिस्ट ने J.J. थॉमसन नाम का जो साइंटिस्ट थे, उन्होंने क्या डिस्कवर किया 1900 में, दो जो एटम्स है वो एटम्स के पार्टिकल्स है वो नॉन डिविजिबल है, और नॉन डिविजिबल है बट उसमें क्या है, सब एटॉमिक पार्टिकल्स है. एंड व्हाट इज द सब एटॉमिक पार्टिकल्स? द सब एटॉमिक पार्टिकल्स आर नोन एज द इलेक्ट्रॉन. Who discovered this? The J.J. Thomason. He discovered that things. 1886, the scientist Goldstein, what he discovered? He discovered that the presence of new radiations in a gas discharge and called them a canal rays. Means he also discovered that electrons are present in the atom. J.J. Thomason as well as Goldstein, both they discovered the same thing. Atoms are indivisible, but atoms are having the electrons in it, sub part of that atom, which is known as the electrons. Okay, and the Goldstein, the scientist E. Goldstein, he discovered with the help of gas discharge and canal rays, with the help of canal rays. Okay, so what is that canal rays? Canal rays are the positively charged particles. These canal rays, these are the positively charged particles and that created in a gas discharge tube. वो जो canal rays है, वो जो positively charged particles है, वो positively charged particles कहाँ create किया है? उनको create किया है वन जो गैस डिस्चार्ज ट्यूब है उसमें, with a high voltage electricity after passing through the gas. Now these rays were positively charged radiations which ultimately led to discovery of another subatomic particles. These subatomic particles had a charge इक्वल इन मैग्नीट्यूड बट अपोजिट इन द साइन टू दैट ऑफ द इलेक्ट्रॉन। यहाँ जो हम अगर देखा जाए तो इलेक्ट्रॉन का चार्ज रहता है नेगेटिव, एंड द पार्टिकल्स which are the particles newly found, they are opposite signs of that electron, means they found whatever they found, these are the positively charged particles. So these types of particles, they given name to it the proton, they given name to this proton. So in general the electron is represented as a E minus, the electron represent as a E minus, and the proton as a P plus. Here if you will see proton P plus, that means electron is carrying the minus charge and proton carrying the positive charge. The mass of proton is taken as 1 unit and its charge as a +1. The mass of electron is considered to be negligible and its charge is the -1. यहाँ देखा जाए तो protons जो है, so protons carrying the positive charge, protons carrying the positive charge, and electrons they are having negative charge. Okay, next point. It seems that an atom was composed of protons and electrons. इसका मतलब क्या है, अब atoms के जो parts होते हैं, atoms is not divisible, that it's final. Okay, but जो atoms के जो parts होते हैं, so these parts are made from the protons and electrons mutually balancing their charges. So ये जो प्रोटॉन्स और इलेक्ट्रॉन्स है वो म्यूचुअली क्या करते हैं, बैलेंस करते हैं एक दूसरे को. इट also appeared that the protons were in the interior of an atom. ये जो प्रोटॉन्स रहते हैं वो प्रोटॉन्स क्या होते हैं, एटम्स के इंटीरियर पार्ट में होते हैं, एंड whereas the electron could easily be removed of but not protons. और जो electrons can easily remove from the atom but proton cannot. Okay, point number 4.2, the structure of an atom. We have learned Dalton's atomic theory. We already learned Dalton's atomic theory in chapter 3, which suggests that the atom was indivisible and indestructible. So atom, we cannot divide that atom into a small pieces, we cannot divide into the small pieces. So atom is the indivisible and indestructible. But the discovery of two fundamental particles, electrons and protons, inside the atom led the failure of aspects of Dalton's atomic theory. The scientists afterwards who discovered the presence of protons and electrons, because of that the Dalton's atomic theory is totally going to fail. It was then considered necessary to know how electrons and protons are arranged within an atom. Okay, to explain that how atoms or how protons and electrons are arranged in between the atom, so for that purpose many scientists proposed different models. J.J. Thomason was the first one who proposed a model for the structure of an atom. जो J.J. Thomason नाम के जो साइंटिस्ट है उन्होंने सबसे पहली बार क्या किया, जो मॉडल है और स्ट्रक्चर ऑफ एन एटम वो प्रपोज किया, डिस्कवर किया. थॉमसन्स मॉडल ऑफ एन एटम. Thomson's proposed the model of an atom to be similar to the Christmas pudding. What is the Christmas pudding? Christmas pudding मतलब क्या, ड्राई फ्रूट ने बनने वाला एक पदार्थ है, खाने वाला पदार्थ, उसको क्या कहते हैं, क्रिसमस पुडिंग. सो ये जो क्रिसमस पुडिंग है वो क्रिसमस पुडिंग ड्राई फ्रूट्स ने बनाया हुआ रहता है. ड्राई फ्रूट मतलब काजू बादाम किशमिश वगैरह वगैरह. द इलेक्ट्रॉन्स इन अ स्पीयर ऑफ पॉजिटिवली चार्ज वेयर लाइक अ करंट. सो जो इलेक्ट्रॉन्स रहते हैं वो इलेक्ट्रॉन्स कैसे रहते हैं, जो ड्राई फ्रूट्स जैसे रहते हैं उस टाइप में क्या रहते हैं, इलेक्ट्रॉन्स रहते हैं. कहाँ रहते हैं वो इलेक्ट्रॉन्स, जो एटम है उस एटम के अंदर लेकिन बाजू में, नॉट इन मिडल सेक्शन. ओके, सो साइंटिस्ट कंपेयर दिस एटम मोलिक्यूल्स एटम्स टू द वाटरमेलन. सो हियर व्हाट गिवन, द वाटरमेलन, द पॉजिटिवली चार्ज in the atom is spread all over like the red edible part of the watermelon, while the electrons are studded in the positively charged sphere like the seed in the watermelon, given figure number 4.1. so यहाँ इस फिगर में क्या दिया है, ये जो पूरा राउंड कलर है, ये राउंड कलर है टोटल एटम. ओके, ये जो एटम है उस एटम में अगर सपोज देखा जाए तो जो वाटरमेलन में जो रेडिश कलर का पार्ट रहता है Okay, so this reddish color part which is present in the watermelon, it is known as the positive sphere, and the seeds which are present inside the watermelon, these are known as the electron. So are you understand how Thomson's model of an atom, he compared their model with the watermelon, or Rutherford's model of an atom. So Ernest Rutherford, the name of scientist, was interested in knowing how the electrons are arranged within an atom. So जो अर्नेस्ट रुदरफोर्ड जो नाम के साइंटिस्ट थे, उनको बहुत उत्सुकता थी. सो उनको क्या जानना था, हाउ इलेक्ट्रॉन्स आर अरेंज्ड विद इन एटम. जो इलेक्ट्रॉन्स रहते हैं वो इलेक्ट्रॉन्स एटम्स में कैसे फिट हो जाते हैं, नहीं तो कैसे दिखते हैं, दैट थिंग्स दे हैव टू नो. Rutherford designed an experiment for this. Rutherford selected gold foil. So why he selected gold foil? The gold, जो गोल्ड होता है वो गोल्ड क्या होता है, उसमें मैलिएबिलिटी एक उसकी प्रॉपर्टी होती है, मैलिएबिलिटी, बिकॉज गोल्ड इज मेटल. So the property which is present in the metal, that is known as the malleability. Malleability में क्या होता है, malleability में जो गोल्ड है उस गोल्ड को अगर प्रेस किया जाए तो उसको वो एक थीन शीट में, स्मॉलेस्ट थीन शीट में वो कन्वर्ट हो सकता है. दैट्स वाई दैट रुदरफोर्ड सिलेक्टेड अ गोल्ड, and this gold foil was about 1000 atoms thick. Alpha particles are doubly charged helium ions. Since they have a mass of 4u, the fast moving alpha particles have considerable amount of energy. वो जो गोल्ड फॉइल है वो गोल्ड फॉइल से अल्फा पार्टिकल्स इमिट किए हैं. सो बिकॉज ऑफ दैट the particles of rays, or we can say the particles of light, which is known as the alpha particles, they send towards that gold foil. Rutherford expect that alpha particles would be deflected by the subatomic particles. Which are the subatomic particles? Electron and that protons, we can say. The alpha particle will deflect by the subatomic particles in the gold atom. वो gold atom में जो gold atom में जो subatomic particles है, electrons, protons, will come back, or they will change their position. So since the alpha particles were much heavier than the protons, he did not expect to see a large deflection. It is the figure of scattering of alpha particles by gold foil. So here the rounded shape structure given, these are known as the atoms of gold foil. So these are the atoms of gold foil, remember that. Okay, and middle, that points given, this is the nucleus. Middle point is known as the nucleus. Now these rays are known as the alpha rays. These rays are known as the alpha rays. If you will see here, the alpha rays particles, when they touch to that atoms, that time they change their direction like this. Some alpha particles, when they attack to that gold foil, they on the same way they come back in 180 Celsius, and some alpha particles, they go in forward direction, they directly go in the, from that they go directly, वो वहाँ से क्या हुए, आगे निकल कर गए. So these are the some conditions when that alpha particles are attacked on the gold foil. Now the alpha particle scattering experiment gave totally unexpected result. जो expect किया था result रुदरफोर्ड ने, उसके बिल्कुल opposite result रुदरफोर्ड को इस experiment से मिला है. So what is that experiment observation? Most of the fast moving alpha particle passed straight through the gold foil. If you will see here, this most of the alpha particles like this, they move forward, they pass straight through the gold foil like this. Okay, they passed from this gold foil. Next one, some of the alpha particles were deflected by the foil by small angle. If you will see here, some alpha particles, when they deflect to that atom, they taken the small angle and they come back. Okay, some alpha particles were deflected by some foil by small angle like this also. This is the small angle. If you will see here also, this is the small angle. It is also, we can say, the small angle, this. Okay, third point, surprisingly 1 out of every 12,000 particles appear to be rebound. So from these some particles, they rebound, means they come in the same direction, 180 degrees, they come back. Okay, so these are the observations which Rutherford found in the after experiment. In the words of Rutherford, this result was almost as incredible as if you fire a 15-inch shell at the piece of tissue paper and it come back and hits you. तो रुदरफोर्ड ने इस एक्सपेरिमेंट का एक सीधे एक एग्जाम्पल दिया है, सीधा एक एग्जाम्पल दिया है. उसने क्या बताया, अगर आप एक टिश्यू पेपर के ऊपर एक छोटा सा पत्थर फेंकते हैं, 15 इंच का पत्थर फेंकते हैं, और वो 15 इंच का पत्थर अगर उस टिश्यू पेपर को टकरा कर वापस आपको ही लग जाए, आपको ही हिट करे, तो वो कैसा रहेगा. सो दैट एक्सपेरिमेंट उन्होंने उससे ये कंक्लूजन निकाला है. किसने? रुदरफोर्ड ने. So let us think of an activity in an open field to understand the implications of this experiment. Let a child stand in front of wall with his eye closed. Let him throw stone at the wall from the distance. एक स्टूडेंट नहीं तो एक बच्चों को क्या किया, एग्जाम्पल में क्या बताया, एक स्टूडेंट को नहीं तो छोटे बच्चों को आँख पर पट्टी बांधकर एक वॉल के सामने खड़ा किया है और उसको बताया है एक वॉल के ऊपर क्या करना है, पत्थर फेंक के मारना है. He will hear a sound when each stone strikes the wall. आँख पे पट्टी है, लेकिन वो जब पत्थर वो वॉल के ऊपर फेंकेगा तब उसको क्या होगा, वो जो साउंड है, पत्थर टकराने का साउंड है वॉल के ऊपर, वो साउंड उसको सुनाई पड़ेगा. If he repeats this 10 times, he will hear the sound 10 times. वो जो बच्चा है, वो बच्चा अगर वॉल के ऊपर 10 बार पत्थर फेंकेगा तो उसको 10 बार ही उसका आवाज़ सुनाई देगा. But if a blind folded child were to throw stones at the barbed wire fence, most of the stones would not hit the fencing and no sound would be heard. This is because there are lots of gaps in the fence which allow the stone to pass through them. अगर ऐसे ही एक बच्चे को अगर जो जाली होती है, जाली उसको कहते हैं बार्ब्ड वायर फेंस, उस जाली के ऊपर अगर पत्थर मारने के लिए बताया तो वो क्या होगा, वो पत्थर उस गैप में से उधर निकल जाएगा, उसके उस बाजू को निकल जाएगा. कुछ ही पत्थर क्या होंगे, वो जाली को लग जाएंगे, लेकिन बहुत सारे पत्थर क्या होंगे, वो जाली के आर पार चले जाएंगे. टाइप कंक्लूजन Rutherford टेकन फ्रॉम हिज एक्सपेरिमेंट. Following similar reasoning, Rutherford concluded from the alpha particles scattering experiment that most of the space inside the atom is empty because most of alpha particles passed through the gold foil without getting deflected. अगर आप यहाँ देखते हैं तो most of the alpha particles they passed from that gold foil without scattering, without deflecting. Okay, so that is the first given the conclusion. Very few particles were deflected from their path, indicating that positive charge of an atom occupies very little space. ऐसे कुछ ही अल्फा रेज पार्टिकल्स है जो who are taken the small angle. Okay, so it means that it indicates that the positive charge of atom occupies very little space. Third conclusion, a very small fraction of alpha particles were deflected by 180 degree, indicating that all positive charge and mass of the gold atom were concentrated in the very small volume with the atom. So in this experiment he concluded these 3 points. From the data he also calculated that the radius of nucleus is about 5th times less than the radius of the atom. So it is a simple point. It means that the radius of an nucleus is smaller than the radius of an atom. So nucleus तो small ही होगा उसमें, और the radius of atom the bigger than the nucleus. Okay, so that is the common thing. On the basis of his experiment, Rutherford put forward the nuclear model of an atom, which had the following features. So इस एक्सपेरिमेंट के ऊपर रुदरफोर्ड ने क्या किया, रुदरफोर्ड ने द न्यूक्लियर मॉडल ऑफ एन एटम ही डिस्कवर्ड. एंड व्हाट आर द फीचर्स ऑफ दैट न्यूक्लियर मॉडल? देयर इज अ पॉजिटिव चार्ज सेंटर in an atom called nucleus. So the positive charge center, which is known as the nucleus, who said Rutherford. Nearly all the mass of an atom resides in the nucleus. So whatever mass we can say of an atom, which derived or described with the help of the nucleus only. The electron revolves around the nucleus in a circular path. According to this Rutherford's experiment, or according to this Rutherford's theory, he said that the electrons revolve around the nucleus in a circular path. Okay, so according to Rutherford, electrons are revolved in a circular path. The size of the nucleus is very small as compared to the size of atom. एटम के बीच में जो न्यूक्लियस है, दैट न्यूक्लियस इज अ वेरी स्मॉल पार्ट विच इज प्रेजेंट इन द एटम. ओके, सो रुदरफोर्ड ने टोटल कितने पॉइंट्स बताए, उसकी न्यूक्लियर थ्योरी क्या है, न्यूक्लियर मॉडल क्या है उसका. द फर्स्ट थिंग, द न्यूक्लियस इज पॉजिटिवली चार्ज्ड. फर्स्ट थिंग, न्यूक्लियस इज वेरी स्मॉल दैन द एटम. So, what are the drawbacks of Rutherford's model of an atom? The revolution of electron in a circular orbit is not expected to be stable. जो रिवॉल्यूशन हो रहा है इलेक्ट्रॉन्स का, किसमें, जो एटम्स का ऑर्बिट में. सो बिकॉज ऑफ दैट एटम्स शुड नॉट बी स्टेबल. एनी पर्टिकुलर इन अ सर्कुलर ऑर्बिट वुड अंडरगो एक्सेलरेशन. जब इलेक्ट्रॉन्स मूव करते हैं एटम्स के अंदर अराउंड द न्यूक्लियस ऑफ दैट एटम, सो दैट इज नॉट द साइन ऑफ स्टेबल एटम. And we know that the atoms are quite stable. So that is the drawback of the Rutherford's theory. Thus, a revolving electron would lose energy and finally fall into the nucleus. When that electrons are rotating around the nucleus, after some time, after some days or after certain time, that electron lose their energy. And when the electrons will lose energy, that time finally they will fall inside the nucleus or on the nucleus, and because of that the whole atom get disturbed, or we can say whole atoms is mostly highly unstable, and hence matter would not exist in the form of that we know. इससे क्या हो जाएगा, जो हमें मैटर का मतलब पता है वो मैटर एग्जिस्ट ही नहीं करेगा. सो दैट इज द बिग ड्रॉबैक ऑफ रुदरफोर्ड्स एटॉमिक मॉडल. नेक्स्ट पॉइंट, बोर्स मॉडल ऑफ एन एटम. सो हु इज दैट बोर? बोर कौन था? नील्स बोर in 1885 to 1962. He was born in Copenhagen in 7th October 1885. He was appointed professor of physics in Copenhagen University in 1960. बोर एक साइंटिस्ट थे, उन्होंने जो उसके काम के लिए उन्होंने नोबेल प्राइज़ भी मिला था, एंड ही इज़ द प्रोफेसर ऑफ फिजिक्स. Among Professor Bohr numerous writing, 3 appearances as a book are The Theory of Spectra and Atomic Constitution, Atomic Theory and the Description Nature. So Bohr is one of the most famous scientists in physics. What is the Bohr's atomic model? In order to overcome the objections raised against Rutherford's model of an atom, after when Rutherford discovered that his model, afterwards most of the scientists taken objections on that Rutherford's model. That नील बोहर पुट फॉरवर्ड द फॉलोइंग पोस्टुलेट्स अबाउट द मॉडल ऑफ एन एटम. सो उसके आगे जाके एक स्टेप नील बोहर ने क्या किया, उसके व्हाट इज द साइंस, व्हाट इज द थिंग्स ऑफ एन मॉडल ही पुट फोर्थ इन फ्रंट ऑफ द वर्ल्ड. ओनली सर्टन स्पेशल ऑर्बिट नोन एज डिस्क्रीट ऑर्बिट्स ऑफ इलेक्ट्रॉन आर अलाउड इनसाइड द एटम. अब बोहर्स का जो मॉडल है, उस मॉडल के मुताबिक कुछ ही इलेक्ट्रॉन्स जो एटम्स के न्यूक्लियस में पार्टिसिपेट कर सकते हैं, इनसाइड उसके जा सकते हैं. वाइल रिवॉल्विंग इन द डिस्क्रीट ऑर्बिट्स द इलेक्ट्रॉन्स डू नॉट रेडिएट एनर्जी. व्हेन दीज इलेक्ट्रॉन्स आर रिवॉल्विंग अराउंड दैट nucleus, that time they will not take part in or they will not lose their energy. When they radiate their energy, only when they jump from one orbit to another orbit. These orbits, or we can say the shells, are called the energy level. So these are the energy level, or we can say these are the shells of an atom. These are the shells of an atom. Okay, so middle one is the nucleus of an atom. So middle part is known as the nucleus. Afterwards, the first part which is present near the nucleus is known as the K shell. Above the K shell, L shell is there. Above the L, M shell is there, and above the M, N shell is there. N shell is there. Okay, so these are the shells present of an atom. Who discovered that one? Bohr's, or in the Bohr's atomic theory. This is known as a few energy level in an atom. Okay, so these orbits or shell are represented by the letters K, L, M, N. Okay, or numbers 1, 2, 3, 4. Now, what are the neutrons? What are the neutrons? In 1932, Chandwick discovered another subatomic particles which had no charge and a mass nearly equal to the protons. Now, the protons present inside the nucleus, the protons having positive charge, the electron present in the orbit which is having negative charge. But here the neutrons, what are the neutrons? It was eventually named as a neutron because the particles which had no charge and mass nearly to the proton, nearly equal to the proton, means neutron that doesn't having any type of charge, so it's named as neutral. Neutrons are present in the nucleus. ये जो न्यूट्रॉन्स है न्यूट्रॉन्स सो कहाँ प्रेजेंट होते हैं न्यूट्रॉन्स ऑल्सो प्रेजेंट इनसाइड द न्यूक्लियस ऑफ एन एटम इट इज प्रेजेंट न्यूक्लियस ऑफ एन एटम एक्सेप्ट हाइड्रोजन एटम छोड़ के बाकी सब न्यूट्रॉन्स आर प्रेजेंट्स विद द प्रोटॉन्स इनसाइड द न्यूक्लियस in the mass of an atom is therefore given by the sum of the masses of protons and neutrons present in the nucleus. Next point, how are electrons distributed in different orbits? The distribution of electron into different orbit of an atom was suggested by Bohrs and Bohrs. The following rules are followed by writing the number of electrons in different energy levels or shells. The maximum number of electrons present in a shell is given by the formula 2n square where n is the orbit number or energy level index, orbit number 1 2 3 4. Okay, these are the orbit numbers. Hence the maximum number of electrons in different shells are as follows. First orbit or k, it is the nucleus. Afterwards k shell is there, then K, L, M, and last one is the N shell. So this type of structure is present of the atom. So first orbit or K shell will be 2 multiplied by 1 square is equal to 2. In second orbit means it is in L shell will be 2 into 2 square is equal to 8. In third orbit M shell 2 into 3 square is equal to 18. And fourth N shell is the 2 into 4 raised to 2 is equal to 34 and so on. The maximum number of electron that can be accommodated in the outermost orbit 8. जो maximum number है electrons का, so that is the accommodated in the outermost orbit of is the 8. The electrons are not accommodated in a given shell. Electron are not accommodated. Accommodated means what? Accommodated means mixing. Okay, और इन जब तक अंदर के शेल जब तक पूरा फिल नहीं होते तब तक क्या होते हैं बाहर के उसमें मिक्स नहीं हो जाते. Unless the inner shells are filled, this is the shells are filled in stepwise manner. Atomic structure of first 18 elements is shown systematically in figure 4.4. So this is the atom of hydrogen. This is the atom of hydrogen. Lithium, beryllium, boron, carbon, nitrogen, oxygen and so on. So these are the structure of hydrogen and helium, and these are the structure of the atomic structure of the first 18 elements. So this is the structure of first 18 element atomic structure. Okay, now next point, valency. The new point is the valency. We have learned how the electrons in an atom are arranged in different shells or orbits. The electrons present in the outermost shell of an atom are known as the valence electrons. Here, if you will see, the electrons are present in the outermost shell. So that is the valence of that particular electron. If you will see any another atom, suppose here oxygen, it is the oxygen. So how many electrons present outside? 1 2 3 4 5 6. So that is the valence electrons. So these outermost, the electrons which is present in outermost shell, these are known as the valence electrons. So in this picture, the systematic atomic structure of an first 18 elements are given here. Now, from the Bohr and Bohrs schemes, we also know that the outermost shell of an atom can accommodate a maximum of 8 electrons. It was observed that the atoms of element completely filled with 8 electrons. So it is most of the atoms, they are having 8 electrons to fulfill their valency. So in other words, their combining capacity or valency is 0. If 8 electrons are present in the outermost shell of an atom, so that is the we can say that valency is the 0. Now, the combining capacity of an atom of element, that is their tendency to react and form molecules with atom of the same or different elements, was thus explained as an attempt to attain fully filled outermost shell. The combining capacity of atoms of element, that is their tendency to react with form molecule with atom, the electrons present in the outermost shell, if electrons are less than 8, so if 7 electrons are present in the outermost shell, then they can accept 1 electron. So that is the tendency to react with become a molecule of particular atom. So an outermost shell which had 8 electrons, suppose that outermost shell had 8 electrons, then we can say that is it possesses the octet. So 8 electrons present in the outermost shell, so it is known as the octet. Atoms would thus react so as to achieve an octet in outermost shell. This was done by sharing, gaining or losing electrons. If electrons are present in outermost shell less than the 8 or more than the 8, so that particular atom can lose or they can gain they can share their electrons to complete its octet. इलेक्ट्रॉन क्या करता है? इलेक्ट्रॉन करता है जो उसके लास्ट शेल में जितने भी इलेक्ट्रॉन्स रहते हैं, एटम्स के लास्ट शेल में जितने भी इलेक्ट्रॉन्स लेते हैं, वो लास्ट शेल में अगर 8 इलेक्ट्रॉन्स से कुछ कम नहीं तो कुछ ज़्यादा इलेक्ट्रॉन्स है तो वो शेयर तो करता है, नहीं तो गेन तो करता है. ओके, सो द नंबर ऑफ इलेक्ट्रॉन्स गेन, लॉस्ट और शेयर्ड सो एज टू मेक द ऑक्टेट ऑफ इलेक्ट्रॉन्स इन आउटरमोस्ट शेल gives us directly the combining capacity of the element. That is the valency discussed in the previous chapter. In last chapter we discussed about the valency. Okay, for example, hydrogen, lithium, sodium atoms contain 1 electron in each of their outermost shell. If you will see here the atom of hydrogen which contain 1 electron in their outermost shell. Then next example, lithium also containing the 1 electron in their outermost shell. Next, sodium also contain 1 electron in their outermost shell. So these are the atoms which contain 1 electron. These are the atoms which contain 1 electron in their outermost shell. Therefore each one of them can lose 1 electron, so they are said to have valency of 1. So they can lose 1 electron to complete their octet, so the valency of that particular atom is known as the 1. Can you tell what is the valency of magnesium and aluminium? So what is the valency of magnesium and aluminium? If you will see the structure of this atomic structure of that magnesium, then we can say that the valency of that magnesium is 2, because 2 electrons are present in outermost shell. Okay, so like this, aluminium is having 3 electrons in their outermost shell, so that is we can say that valency of that one, magnesium and aluminium, is 2 and 3 respectively. Magnesium has 2 electrons in its outermost shell and aluminium has 3 electrons in its outermost shell. Okay, if the number of electrons in the outermost shell of an atom is close to its full capacity. Now यहाँ इन्होंने क्या दिया है? the number of electrons which are present in outermost shell. लास्ट सेल में अगर उसके जो फुलफिल करने के लिए एटम्स इलेक्ट्रॉन जितने चाहिए उसके नज़दीक अगर कोई भी इलेक्ट्रॉन्स उसमें है, देन वैलेंसी डिटरमाइंड इन डिफरेंट वे. तो वहाँ वैलेंसी उसका मेजर करने के लिए एक अनोखा तरीका है. फॉर एग्जाम्पल, द फ्लोरीन atom has 7 electrons in their outermost shell. So we'll count that 1, 2, 3, 4, 5, 6, 7. 7 electrons in their outermost shell, and the valency could be 7. But it is easier for fluorine to gain 1 electron instead of losing 7 electrons. So in this case, fluorine will accept or gain 1 electron from outside. So the valency of fluorine is the 1. Okay, because it will gain 1 electron to complete their octet. Hence the valency determines the subtracting 7 electrons from octet, and this gives you valency of 1 for the fluorine. Valency can be calculated in a similar manner for oxygen. We will see the one example of oxygen here. It is the atom of oxygen. If you will see how many electrons present outside shell, 1, 2, 3, 4, 5, 6 electrons are present outside of the shell. So what will be the easy way to become a complete its octet. So 6 electrons are present outside, plus to complete its octet it need more 2 electrons. So we will say here valency of oxygen is 2. Okay, so next one, therefore atomic number and mass number. Our new point is the atomic number. We know that protons are present in the nucleus. So where are protons present? Protons present inside the nucleus. Suppose it is the structure of an atom where nucleus is situated in middle. So protons and neutrons, they both are present inside the nucleus, and electrons are present in the orbit. Okay, so electrons present are here. Electrons are denoted by minus sign and protons are denoted by plus sign, that we already learned. So and the neutrons are neutral. Okay, so protons are present inside the nucleus. It is the number of protons of an atom. It is the number of protons of an atom which determines its atomic number. The protons present inside the nucleus, suppose 2 protons are present inside the nucleus, so that is the 2 is the atomic number of given particular atom. So suppose 5 protons are present inside the nucleus. Okay, 5 protons present inside the nucleus, so that is the 5 is the atomic number of an atom. Understood? Yes. It is denoted by Z. The atomic number is denoted by capital Z. All atoms of an element have the same atomic number, Z. In fact, elements are defined by the number of protons they possess. For hydrogen, Z is equal to 1, because how many protons are present there? Only 1. Only 1 proton is present inside the nucleus of hydrogen, so atomic number is equal to capital Z is equal to 1. Similarly, for carbon, if you will see, the 6 protons are present inside the nucleus of carbon. You see the 6 electrons present in the orbit of an particular atom. 1 2 3 4 5 6 1 2 3 4 5 6. Okay, 6 electrons are present in the orbit of the nucleus and 6 protons are present here, so the atomic number of an carbon is the 6. Okay, so that is the simple term. It can ask for 1 or 2 marks in board exam also, in your main exam also. Next one, mass number. What is the mass number? After studying the properties of the subatomic particles of an atom, we conclude the mass of an atom is practically due to the protons and neutrons alone. These are present in the nucleus of an atom. Hence, protons and neutrons are also called nucleons. These protons and neutrons combinedly called as the nucleons. Therefore, the mass of an atom resides in its nucleus. For example, mass of carbon is 12 U because it has 6 protons and 6 neutrons. So 6 plus 6 is equal to 12 U. Similarly, the mass of aluminium is 27 mu, 13 protons plus 14 neutrons. The mass number is defined as the sum of the total number of protons and the neutrons present in the nucleus of an atom. It is denoted by capital A. The mass number is denoted by the capital A. In the notations for an atom, the atomic number, mass number and symbols of element are to be written as. While writing the symbol of any particular atom, the writing should be X. X is the any particular atom name or element name or symbol of an element. The mass number, which is writing above the element name, and atomic number at the base. Okay, they both are the left side up and left side base. For example, nitrogen is written as this is the symbol of nitrogen N. 14 is the number of mass number and 7 is the, we can say that, atomic number. Next point, isotopes. नाउ द आइसोटोप्स इज़ वेरी सिंपल. आइसोटोप्स बहुत एक सिंपल कंसेप्ट है. यहाँ आइसोटोप्स में क्या होता है, आइसोटोप्स हैविंग द डेफिनाइट एटम्स ऑफ द सेम एलिमेंट हैविंग द सेम एटॉमिक नंबर. जो आइसोटोप्स होते हैं, जो एलिमेंट्स होते हैं, उसका एटॉमिक नंबर सेम रहता है बट दे आर हैविंग डिफरेंट मास नंबर. मतलब यहाँ आइसोटोप्स में क्या रहता है, सपोज एग्जाम्पल ऑफ आइसोटोप्स इज अ कार्बन. Carbon is one example. Carbon is one example of isotopes. So here in the carbon, the atomic mass number is different. Suppose this is the carbon and atomic mass is a different, but the atomic number is same. What is the atomic number of carbon? 6. 6 is the atomic number of carbon. Okay. So here यहाँ अगर आप देखा जाए तो 6 is the atomic number which is same. 6 is the atomic number of carbon which is same, but the mass number of carbon is a different. So that is the simple thing. So this is known as the isotopes. Okay, now we will see another example. Here if you will consider about chlorine, Cl and Cl. Okay, it is the chlorine. The atomic number of chlorine is 17, okay, which is same in these isotopes, and the number of mass number is a different. So in this case the atomic mass of chlorine is 35 in one case and 37. So this is known as the isotopes. So in simple language, what is the isotopes? And this isotopes, ये जो isotope नाम का जो word है, this isotope concepts, this word come from the Greek word. So isos and topos, it means that same place. So this isotope term derived from Greek word, so which means that same place. Here once again I will repeat the definition of isotopes. What is the isotopes? Isotopes are defined as the atoms of the same element having the same atomic number but different mass number. Therefore we can say that there are 3 isotopes of hydrogen atom, namely protium, deuterium and tritium. So this is the example of hydrogen given here. Okay, next point. Now according to definition of isotopes, they are having the same atomic number but different mass number. So if you will see any element, these elements are made from the mixture of isotopes. Suppose here we saw the example of carbon or chlorine or hydrogen also. So in this case the atomic numbers are same but mass numbers are different. Same way, if you will see the particular element, suppose carbon is there, hydrogen is there, chlorine is there, or another any isotopes is there, so they are having the mixture of different isotopes. One element, they are having the mixture of different isotopes. Each isotope of the element is a pure substance. The chemical properties of isotopes are similar. Now here most important point, chemical properties of isotopes are similar but the physical properties of isotopes are different. Okay, now here for example chlorine occurs in nature in 2 isotopic forms with masses 35u and 37 mu. Okay, in the ratio of 3:1, means out of 100 75 and another one is the 25. Okay, so it is known as the 3:1. Obviously the question arises that what should we take as the mass of chlorine atom. Okay, so actually which mass we have to take for next preparation or calculation. Okay, so there is one method to calculate the mass of that chlorine. Okay, so here the examples given, the one atomic number given 35, atomic mass of chlorine is the 35 and atomic mass of another isotope of chlorine is the 37. If you will see here 35 and 37, so this is the 3:1. Okay, 75 upon 100 and 25 upon 100. Okay, now if we will calculate this, then in simple way we will calculate this. So 35 multiplied by 75, it goes to 2625 divided by 100. Okay, and plus sign is there, and 37 multiplied by 25, so 925 upon 100. Okay, so is equal to, if you will give simplify it, then answer will become 71 divided by 2 is equal to 35 35.5. Same answer is here also same answer. You can calculate with this method also, but I feel this is the simple method, so I calculate here with this method. So if you will see here, the atomic mass of the chlorine is the 35.5 mu. Next one, the mass of an atom of any natural element is taken as the average mass of all naturally occurring atoms of the element. If an element has no isotopes, अगर बहुत सारे ऐसे एलिमेंट्स है उसको आइसोटोप्स ही नहीं होता है, ओके, सो फॉर दैट पर्पज व्हाट, देन द मास ऑफ एटम वुड बी द सेम एज द सम ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स. ओके, सो हाउ वी कैन कैलकुलेट दैट वी ऑलरेडी नो दैट हाउ वी कैन कैलकुलेट द मास ऑफ एनी एटम. सो वी आर एडिंग प्रोटॉन्स एंड न्यूट्रॉन्स फ्रॉम that particular element. Okay, but if an element occurs in isotopic form, if element, अगर यहाँ elements के isotopic forms से elements are found in the mixture of isotopes, then what we have to do, then we have to know the percentage of each isotopic form and then the average mass is calculated. So if any particular element found in the isotopic form, then we have to know about its percentage of each isotopic form, then and then only we can calculate the mass. Now next one, this does not mean that any one atom of chlorine has a fractional mass of 35.5 mu. It means that if you will take the chlorine for particular reaction or for any another purpose, then this chlorine contain both isotopes. Okay, now what are the applications of these isotopes application? First one, an isotopes of uranium is used as a fuel in nuclear reactor. Okay, जो यूरेनियम का यूज़ होता है वो न्यूक्लियर मतलब they are using in a nuclear reactions, means जो यूरेनियम के फैक्ट्रीज रहते हैं वहाँ, otherwise to preparation of blasting atoms, uranium can use there. So which are the isotopes of uranium? The isotopes of uranium is the uranium 238, uranium 235. So these are the isotopes of uranium. And what is the uses of uranium? It is used as a fuel in a nuclear reactor. So another one is an isotopes of cobalt is used in the treatment of cancer. The isotopes of cobalt. Okay, cobalt is also having the isotopes. This isotopes of cobalt is used in the treatment of cancer. So which are the isotopes of cobalt? Cobalt 59, cobalt 57, cobalt 60, cobalt 56 or cobalt 58. So these are the some examples of isotopes of cobalt. Okay, next one, isotopes of iodine. Iodine is used in the treatment of goiter. Okay, आपको पता ही होगा goiter जो एक बीमारी है. Okay, उस बीमारी के ऊपर, डिसीज के ऊपर आयोडीन के isotopes यूज होते हैं. So which are the isotopes of this iodine? The isotopes of iodine is the iodine 131, iodine 123. Okay, so these are the examples of iodine, isotopes of iodines. Next and simple point is the isobars. Okay, एग्जाम में isotopes और isobars इसके ऊपर दो नहीं तो near about 2 or 3 marks question can ask your teacher. So what is the isobars? Isobars is also very simple concept. Atoms of different elements with different atomic numbers which have the same mass number are known as the isobars. It is actually vice versa of isotopes. यहाँ क्या है अभी? Isotopes, these isobars, they are having the different element with different atomic numbers. Atoms of different element with different atomic numbers which have same mass number. यहाँ क्या है अभी? The mass number is the same but atomic number is the different. They are known as the isobars. Okay, so if you will see here the calcium, if you will see here the example of calcium, atomic number is 20, atomic number is the 20, and argon, the atomic number is the 18. Okay, but the proton in these atoms is different but mass number of both these elements is the 40. Suppose argon Ar and calcium, they both are having the same atomic mass number. Okay, they are having the same mass number but different atomic number. Calcium is having 20 and argon is 18. Okay, and exactly opposite क्या था? Isotopes में था. Okay, so in isobars the element name is different and the atomic number is different but this mass number is the same. Okay, so So in this way we have to complete our lesson number 4, structure of the atom. From this lesson we learn charged particles in matter. Again we saw the structure of an atom according to Thomason's model of an atom, then Rutherford's model of an atom. There are some drawbacks. In Rutherford's he used there the golden foil, then alpha particles, and his experiment we learn here. Afterwards we learn some drawbacks. Okay, then we learn the next point, Bohr's model of an atom. Okay, the next one we learn the different shells or structure of atom. Okay, afterwards we learn the next point, valency. In that valency there is a one table 4.1, composition of an atom of the first 18 elements. Okay, so here you have to by heart, आपको ध्यान में रखना पड़ेगा ये टेबल. उसके डिफरेंट एलिमेंट्स गिवन देयर, वहाँ बहुत सारे एलिमेंट्स 18 एलिमेंट्स आपको दिए गए हैं, उसके सिंबल से, उसके एटॉमिक नंबर से और वैलेंस से, ये आपको ध्यान में रखना पड़ेगा. नाउ आफ्टरवर्ड्स वी लर्न द नेक्स्ट पॉइंट, एटॉमिक नंबर एंड एटॉमिक मास. सो फ्रॉम दैट वी लर्न simple but important point, isotopes and isobars. In this way we have finished this our lesson. चलो वीडियो के लास्ट में अब हम आपको एक बात बताते हैं, एक सिंपल ट्रिक बताते हैं. उसके वजह से आप क्या कर सकते हैं, जो पहले 20 एलिमेंट्स है उसके नाम से एटॉमिक नंबर्स एंड सिंबल्स आप ध्यान में रख सकते हैं. सो वन वर्ड इज देयर टू रिमेंबर द फर्स्ट 10 एलिमेंट्स. ओके, पहले 10 एलिमेंट्स ध्यान में रखने के लिए एक सेंटेंस है, एक फ्रेज है, वो आपको ध्यान में रखना है. हाय हेलो लिसन BBC न्यूज़ ऑन फ्राइडे नाइट. ओके, एक बार फिर से सुनो, हाय हेलो लिसन BBC न्यूज़ ऑन फ्राइडे नाइट. सो ये क्या है, हाय हेलो लिसन, hello H means hydrogen, lithium. Then next one is the BBC beryllium, boron, carbon, news, nitrogen. Okay, O oxygen, Friday fluorine, and night means N for the neon, Ne for the neon. Okay, so this is the simple trick to remember the first 10 atomic numbers. Now I will tell you the next sentence to remember the next 10 atomic elements name. नेक्स्ट 11 से 20 तक जो एलिमेंट्स है उसके नाम याद रखने के लिए एक सिंपल ट्रिक है, एक सिंपल फ्रेज है, सेंटेंस है, ना मांगो अलमाइटी से पेप्सी सोडा कोला और काजू केक. फिर से एक बार मैं आपको ये सेंटेंस बताता हूँ, ना मांगो अलमाइटी से पेप्सी सोडा कोला और काजू केक. सो हियर Na stands for the formula of it, or chemical formula is known as the sodium. Mango, M is the magnesium, Mg stand for the magnesium. Almighty, Al, aluminium. Se, so here Se means silicon. Then Pepsi, P stand for phosphorus. Soda, sulfur. Cola, chlorine. Argon, argon. Kaju, potassium. And cake stand for the calcium. So here this is the simple way to remember the first 20 elements, their formula and their atomic number. ये एक सिंपल ट्रिक है. यहाँ ये जो 2 सेंटेंस मैंने आपको जो बताए उसके मदद से आप क्या कर सकते हो, ये जो फर्स्ट 20 एलिमेंट्स है उसके जो केमिकल नेम्स है, एटॉमिक नंबर से, ये आप ध्यान में रख सकते हो. और इट विल बी मोर कन्वीनियंट, मोर इजी फॉर यू टू राइट इन द एग्जाम, टू रिमेंबर देयर एटॉमिक नंबर, टू रिमेंबर देयर एटॉमिक मास, टू रिमेंबर देयर केमिकल फॉर्मूला, देयर नेम, शॉर्ट फॉर्म्स, एक्सेट्रा. So understand, I will repeat that both phrases and sentences. For first 10, the hi hello listen BBC news on Friday night, and the second one is the na mango almighty se Pepsi soda cola or kaju cake. So in this way we have finished our lesson number 4. If you have any doubt, ask me in a comment box. Thank you.